Hello everyone. Today here we have a JEE question on application of derivatives, and it is a question based on increasing and decreasing functions. Okay. So we know that when do you say that a function is increasing? If f dash of x is greater than or equal to 0. Correct? Now the question is, if f of x equals to e to the power x minus x and g of x equals to x square minus x for all x belonging to R, then the set of all x belonging to R where h of x is defined as f composition g is increasing for which of the following intervals? So basically we have to show that this is an increasing function which is h of x. Now it is increasing in which interval we have to find out. So before finding out h dash of x, we have to find out h of x, which is f composition g. Therefore h of x can be written as f of g of x. Is that correct? Now f of g. What is g here? X square minus x. Now what is f here? E to the power x. So it becomes e to the power x square minus x, which is x square minus x. So definitely this is your h of x. Now they say that h of x is an increasing function. That means h dash of x should be greater than or equal to 0. Correct? So we have to find out the derivative of h now. Okay. So the derivative of h would be e to the power x is e to the power x, but in place of x we have x square minus x, which becomes 2x minus 1. And similarly here the derivative is 2x minus 1. Now we can take 2x minus 1 common from both the terms. So what remains here? E to the power x square minus x minus 1. Okay. So what they say, it is an increasing function. So since it is an increasing function, I can write this as greater than or equal to 0. Now, since we have two factors and they say that it has to be increasing, that it is positive, then that means either both has to be positive or both have to be negative. Correct? Because plus into plus is plus, minus into minus is plus. Okay. So we will get two conditions here. First, if both are positive, both have to be positive. Yes. Then only that product is 0. So either this is positive or this is positive. Okay. So if I solve here, what do I get? X is greater than or equal to 1 by 2. Now here, if I solve this, x square minus x is greater than or equal to 1. If I take log on both sides, this becomes x square minus x and this becomes 0. Correct? Because log 1 is 0. Now what this says? X minus 1 is greater than or equal to 0. So again, this product has to be positive. So let us see what all the roots I'll get here. From here I'll get 0. From here I'll get 1. Is that correct? Now, when it is where it is positive, let us see what they say. It has to be again positive, greater than 0 or equal to 0. If you take 0 to 1, it will be negative here. Okay. If you take greater than 1, it will be positive here and it will be positive here also. So basically here to here it is positive and 1 to infinity it is positive. Also we have to combine this with greater than or equal to 1 by 2. So here it is 1 by 2. So this is positive for greater than or equal to 1 by 2. So clearly if you see, if you combine all, the intersection of x greater than or equal to 1 by 2 and the intersection of x into x minus 1 greater than or equal to 0 is definitely 1 to infinity. This is the intersection from first point. Correct? Similarly, we will find the second case. What was the second case? These both will be positive. This product will be positive if both are negative. Both are negative means 2x minus 1 is less than or equal to 0 or x is less than or equal to 1 by 2. Similarly, the second one, that is e to the power x square, okay, is less than or equal to 1. If I shift the minus 1 on the other hand, again if I take log on both sides, what I'll get here? X into x minus 1 is less than or equal to 0. Correct? So what it says, now what are the roots here? 1 I'll get 0, 1 I'll get 1. So this is infinity minus infinity. Now they say that it has to be negative. This product has to be negative. So where it is negative? In 0 to 1, it is negative, because just now we found out 0 to 1 it is negative, 1 to infinity positive, and on the other hand it is positive. Fine. Also, we have to check for 1 by 2 intersection. So where it is negative again, I mean less or equal to 1 by 2 means this portion. Yes. So if I find this is our solution and this is our solution. So clearly, if you see, the intersection of both the solution is from where to where? 0 to 1 by 2. Correct? So if you combine both this and this, if I combine both, the answer is 0 to 1 by 2 union 1 to infinity. So in this interval, your function is going to be increasing function. For that, the answer is option B. Thank you.